little bit different topic than you guys have dealt with in a little bit here last couple of days. This is dealing with securing your keys in terms of the DevOps cycle. How does that differ from the normal, traditional waterfall, on-premise type application structure? Okay, so we're going to talk about that from the couple perspectives here. First of all, my name is Joe Burch. I'm a technical director in Optiv in the Digital Access Management Program. Been doing this stuff for about 20 years in IT. I've been doing, I would say, the identity and PAM for at least 10 to 15 of that, so long time. So we're going to talk about some of this. I tend to wander, so forgive me. And I'm not big on slides, so I apologize for a lot of the notes here, so we'll just talk about some of this. The main difference between the traditional and the DevOps side. DevOps is very quick. You may have 300 plus changes a day. On the traditional, you have maybe one every 6 months, and depending on the situation. They're getting quicker, but traditional development is much, much slower, and each of the products that's coming out of that are full releases, as opposed to every part of the DevOps side potentially being its own individual project. So there are companies using DevOps out there right now that are literally making 300, 400 or 500 changes a day, and it's about speed to market, getting that application bug fixes and or new features very quickly and rapidly out there. Again, the change control process is very tightly controlled on the traditional side, which means you go through all types of review boards and things like that. It could take you 2 or 3 weeks to get a change order done, depending on the severity of that application or the risk of that application. And a DevOps side, there may not be any change process. It may be just a situation where everything's automatically tested and pushed through, okay? Traditional applitions are often manually deployed by their teams. So as a developer, as a part of this process, a product is produced and an IT team of some type will deploy that on behalf of the business or on behalf of that particular development team. In DevOps, it's all controlled it's often controlled within that same space, okay? You don't have a lot of external teams directly impacted or directly working with this code base. Very structured development. Again, we're talking about that with the Agile and the Waterfall. Has a lot of control, a lot of documentation, those types of things. You have physical, virtual, and container deployment in the traditional, whereas in the DevOps, it's highly containerized, which means that we have now basically allowed each of the components within our applications to become smaller and smaller and maybe do one purpose. We can rip and replace that one piece out without replacing the entire application, okay, or doing massive code changes to the application. Excuse me. The infrastructure is also static in a traditional situation. In the DevOps, I might have servers being spun up and down, containers being spun up and down depending on the demand for that application real time. I mean, it could be literally hundreds and hundreds up and down constantly. So it's very hard to dictate what that's going to look like. In a traditional environment, you have X number of servers, and that's normally pretty static, okay? And again, we have different credentials here. We have secrets and endpoint credentials. Endpoint credentials, in this case, would be anything that would be on like a database. It could be a Windows OS account or a Unix OS account or some of that nature. Secrets could be API keys, something very short-lived, or it could be long-lived. But it's something that is normally the traditional side doesn't really deal with that so much. It's more along the endpoint credentials, excuse me. And again, the main difference between the two is the fact very automated in the DevOps side, the traditional is not so much. Okay, so what are the challenges here? We've talked about the overall structure of this. What does that mean for you guys, or in general? Well, it's very complex. If I have traditional I might have an application that spins across, everything from AIX servers to, Windows to SQL databases to Oracle databases, all using the same set of credentials. Because back in the day, that was what happened. We used the same credential for everything. It was easier. So if I'm going to try to manage those credentials, I have to do it that way. It may require multiple teams depending on where the credential lives. If I have to get an AIX team involved in order to touch an account credential, now I'm dealing with a ticket or some other type of change management process to have them involved during my change. I'm now involving more and more of the organization, and in many cases it becomes a situation where you have an enterprise level change. Now you only can do that very, very infrequently, okay? Often has to be coordinated with development cycles. So we don't change credentials willy-nilly as a general rule because it becomes very problematic for that. Why is this all important though? Why do we care about credentials changing in applications? Well, if I'm an attacker, if I can impersonate that application, I get access to that same piece of data. I can download your database. I can download your information. If I steal an API key, I can potentially grab your entire application depending how it's set up. So that's why it's important here. One password change can actually destroy business productivity completely, take an application down. I've seen instances where one password change has actually caused complete outages in a certain part of that application entirely. So DevOps, secrets are not changed, and once exposed, are often very hard to change. So you've probably heard this 1,000 times of people uploading their API keys up into places like GitHub and places like that, where someone has accidentally loaded that key up there. Well, if that API key is across a bunch of different pieces of application code, it's now out there for everybody. I've now potentially breached that application. It's very hard for me to change that. The only way to change it is for you guys to potentially go out and have to create a new key and insert that key in every piece of code out there, which can be very problematic, sneaker net, if you will. Any secret, and that's what we're talking about, required touching several pieces of code to make that change. Aligned exclusive with application. So what I'm saying by this is DevOps has, because of being as new as it is, has really started to separate out the idea that human identities and machine identity or application identities are separate constructs. They should not be used the same way. I should not have a human account touching an API key potentially, those types of things. Or I should not have a human account touching an application account, or human account impersonating an application account. And the other problem is there's no real way to challenge for multi-factor. So it's an API key. I really don't have a way to say, okay, now give me the one-time token or one-time PIN, those types of things. Okay. So how are each addressed? So we've talked about the overall structure of this from the what's the problem. So in this case, a privileged traditional application, we've got the on-server or credential retrieval via remote web API. Okay, there are several different products out there now that have now leveraged API code or WSDL type situation, things like that, in order to allow you to pull your credential real time from some type of storage solution, okay? That's one thing that's come out very heavily recently. Sometimes you have an agent on the box. Well, that's great if I have a server that's gonna be static and not changing constantly. If I have to worry about deprovisioning and reprovisioning agents constantly every time I want to change something, that becomes a very highly problematic situation for those managing those particular accounts. Okay, and that's where there's significant effort to scale. So if I wanted to add 100 servers to this, well, what does that look like? Well, on the DevOps side, it doesn't matter, because DevOps goes, okay, fine. Everything's containerized. Everything is a microservice, if you will. I can rip and replace code at will. So I just put out a key of some type that can be rotated. I rotate that one key, it goes across everything. Again, API calls are still involved because we don't really want to install anything agent-wise on that server or on that container. We want it to be completely, if I want to rip and replace it, I want to be able to do it real time without having to worry about redoing coding all the time. So we have something on machine identity. And that could be some type of, a tattoo, if you will, on that machine, container, if you will, that says you have been authorized to use this, okay? By doing it this way, it's infinitely scalable. So what that means is, as I want to deploy new versions of this or new instances of this, regardless of where they happen to be, with everything going to the cloud and moving to the cloud, moving to all these different containerized situations, it makes it easier for me to expand and change my application real time, which is what a lot of the customers want now. Clients they don't want to wait for 3 months for an application code change to happen when you've got a bug that they want to fix now. That's what this allows. And the other problem is here, this is where your operation and your development team have now kind of merged. Again, that separation occurred before. Now it's starting to come down to the fact we have all the roles of these teams being merged into one. So that one team is doing everything now. They may not have all the knowledge necessary to do all this. So how do you handle that? So what can you do? We've talked about the problems again. We've talked about some of the concerns. So DevOps, traditional pose their own challenges. You have to look at each one as a separate entity. You cannot look at it as a whole. Some products work better with the traditional side, and some products work better with the DevOps side. You need to mix and match where it makes sense. And it could be different vendors potentially. If that works better for you guys, that's fine. The key is to manage those credentials. Get something around there so you can manage them. Again, there's no one-size-fits-all approach. What does that look like? So just because company A uses solution B, A and B, doesn't mean that company C can use those solutions. Could be 1,000 different reasons why. Everything needs to be looked at separately. There are many solutions to assist in managing these credentials, open source and vendor. I mean, right now I know of at least 4 or 5 open source products for the DevOps side you can use. There's at least 4 or 5 different versions on the traditional application side you can use to manage these application credentials. The key is to start managing them. And it comes down to the fact of treating them as true identities. Use the IAM system to provision them. Go ahead and go to that level and treat them like you would any other user account. At the end of the day, the application team owns these accounts. The application owner owns these accounts, not the solution owner. So like, for example, the DevOps product that you put in place should not be owning those credentials. They're a storage facility for those credentials, and that's it. They're a service. So basically, the key takeaway here is to start rotating credentials in code, regardless of how often. It shouldn't matter. It should not matter. Now, having said that, I'm not oblivious to the fact that it's a very easy thing to say and a very hard thing to execute, especially when you got legacy code out there and things like that. It's something you have to watch out for. You have to look at everything, and even if you don't get it all to start with, at least some of it. Start working towards some of it, it makes a difference. Even if there's some manual processes until you can get the rest of it done. So let's say I can change the DevOps side real quick because I can get an open source tool, but I may not be able to change the traditional side for a period of time. Well, I might be able to do some type of situation where I'm changing both using basically a manual process if necessary. But get those credentials rotating, because the longer they're out there, the easier it is for a user, or excuse me, an attacker to use those credentials and do some real damage and take your basically your keys to the kingdom, if you will, your HR databases, your financial databases, and use them against you potentially. Okay, so I know I've went a little bit faster than I expected here, but I've got some time for some questions if you guys want. Yeah, go ahead.
When you say rotating keys in code, so it
Mm-hmm.
means that you call that open source product or anything via an API?
Correct.
Okay.
Yeah, there's tools out there that will allow you to rotate, basically, instead of the API key being stored in the code, it's stored in this, basically this vault situation or this privileged access management solution, regardless of what it is. The idea is I can rotate those credentials, and then it pushes it out to the rest of them when they come back and get their code base. When they execute the code, that's when they come out and grab that credential. So it doesn't matter if someone does grab my code, all they've got is the base calls and nothing more. Does that answer the question? And the question that was asked is, basically, how does the API keys get rotated? Is that correct? Okay. Sorry, I forgot to repeat that. Anybody else? Go ahead.
Can you name those vendors?
I'll do it off camera. I was told specifically, stay away from vendors. But there's a lot of vendors out there. Any other questions? Okay. I'll let you guys have some time back.